So I'm here to try my best so you are awake and not sleeping during my conference, because I'm the last one, and you should be tired. So I'll try to make it fast and interesting. Well, I'm going to talk about large databases, lots of servers, on-premises, in the cloud, but actually, I'm going to open the Pandora box. I'm going to talk to you about the Le Bon Coin case. Who knows Le Bon Coin here? Okay, Sarkozy is not in the room. He's the only one that doesn't know Le Bon Coin. So, this is actually a stack. What is a stack? We have some application servers, we have some front-end servers, we have some border equipment, switches, routers, everything you know to connect your infrastructure to the internet. And in the bottom, we have databases. It's always like that. Databases are always in the bottom of the stack. And usually, they are the part of the stack that are hard to scale out. You know that. You all know that. And if you have put some application in production on the internet, you have seen this. You have seen a stack like that, I'm sure. But, like me, I work at Le Bon Coin. This is the homepage of Le Bon Coin. You all know that. We have exactly this at Le Bon Coin. But this was at 2009. And who knows what this is? Someone? Louder. Zlony. At 2009, Postgres didn't have streaming replication yet, and we used Zlony at Le Bon Coin. It worked. But things have to improve, things have to go further, and around 2013, we still used Zlony. But we replicated from one master database over 2 standby databases, because we needed to scale out. It's necessary to scale out. If someone arrives to you and says, Postgres doesn't scale out, he's lying. Don't let him. Don't let someone say that Postgres doesn't scale out. It scales out since 2008, 2009. We can scale out Postgres with external tools like Zlony. So, other than 2 standbys to load balance, we've had a standby, a spare standby. Like someone said today, you need one server to fail over in case of incident. That's what we had at 2013. And if you compare this stack to this growing stack, we have more servers, because Le Bon Coin was growing in audience. And as a growing company, things have to evolve. And still at 2013, we've had BI, business intelligence, data analytics. And we needed some database for that. And it happens to be Postgres, replicated with Zlony. Or, in the case, we've had the ETL server that connected to the master database or some of the standby servers to feed the BI database, the data warehouse. So things are growing. Today, Le Bon Coin has this, 28.1 million visitors, 27 million ads online, 800,000 new ads per day. So you can have an idea of the volume, and 73 categories of ads. So to handle all of that, we have this today. If you think that Le Bon Coin is just a guy in the basement trying to put some web server online, think again. So today, what we have here is not all the Le Bon Coin infrastructure. it doesn't fit a single slide. But I'd like to say that the simple stack from the first slide is here. And around 2013 is here. And what do you see here that we don't have anymore? Slowly, because today we have streaming replication. And we have other services that were added to the infrastructure that use Postgres, and we have always a couple of servers to fail over if needed. We need high availability. And if you see here, the most interesting stuff here, I think, is this bunch of servers just here. If you count them, they are 20. Yes, this is one single database that has 19 standby servers that will load balance over it. So Postgres scales out. And if you look at the numbers here, this is web scale. So we put 20 servers for that. If needed, I can put another 20 servers, no problem at all. Postgres can web scale. Another lie, if someone say Postgres does not web scale. So here we have some internal applications that are for internal users only. They're not connected to the internet. And these services have Postgres databases. So Le Bon Coin is a Postgres powerhouse. What is the technical stack we have? 2 data centers, 1 cloud provider. I forgot to say. The cloudy servers are on the cloud. So we have 2 data centers on our premises, and we have 1 cloud provider to be on the cloud. We are modern. If you're not in the cloud, you're old. 2,000 virtual machines and several real ones. 20 gigabits per second on the border. It's really our record from the last week, the top of the last week. And if someone has this same slide from 1 year ago or 2, it says that we had 6 terabytes in the main database. Now we have 3. We have shrinked. Actually, we got the historical data from the main database to an archive database that today is 16 terabytes. Am I big data? I think so. So this 3 terabytes database is one or the largest live database of Le Bon Coin. But we still have larger database than that. 3,000 million images that are not on the database. And other things that may interest you, we have 200 people in the tech staff and more than 900 people on the whole staff. Well, how to handle all of this? We just connect SSH server, okay, apt-get, install Postgres. No, actually, we are used to cloud computing today, and everything has to be automated. How do we automate real servers? We push a button, and then a robot comes with the server and puts on the rack and cables everything. So it doesn't exist, but we have Netbox that can help us to talk with a provider that will do this for us. So when a server is bought, it arrives at the data center, it's registered in the Netbox, and then we can say to Netbox what we want the server to do. And so the contractor will make it for us. So it's a bit like cloud computing, but in the old fashion. But it works. We have Collins that is provisioning for new servers. We can say to Collins what operating system to install to the server. It provides a DHCP with an image of the operation or the operating system, and it does it for us. If we are on the cloud, we use CloudFormation to automate the cloud deployment, and After installation of the operating system, we use Puppet for all the automation after install. So, let's talk about availability. Everyone asks me, how do you do high availability in Postgres? Of course, we have replicas. But if you're old like me, you know that bad hardware is bad for you. It's bad for your data. If you are running databases in shelf hardware, you are going wrong, very wrong. This is a route to hell. Because if you have bad disks, you lose your database. If you have bad memory, you have corrupted database. So the first thing for real availability is good hardware, and it costs a lot of money. This is one of our database servers. It's a Hewlett-Packard. I forgot exactly the model, but it's okay. It's good hardware. We have 3 terabytes of RAM inside the server. So if you think that your database has to fit in RAM, you have to buy a lot of RAM. All the hardware is under warranty. The power is doubled. So we have a redundant power supply that is connected to 2 different power lines. We have always RAID 10 for disks. Doesn't matter if it's magnetic disks or SSD, it's always RAID 10. Don't go RAID 6, don't go RAID 5. Don't listen to the buying sector, the buying area of your company. But it's more expensive to have RAID 10. Doesn't matter. Data is expensive. Do you agree with me? So my data is my asset, my more expensive asset. I won't play with it. So RAID 10. Battery backed cache. If you have an internal controller in your server, battery in the controller. If you have an external SAN bay, battery on the SAN bay, no questions asked. Just install that. ECC RAN is the most important thing in quality. If you have money to expand in your server, ECC RAM is not one of the things that I don't discuss. Because if you have data corruption in memory, you will have data corruption in disk. When Postgres checkpoints data from memory to disk, if data is corrupt in memory, you've lost your database. You will need to have doubled network cards. At least 2 paths from the server to the routers. And if possible, 2 separate routers. That costs a lot of money. You have redundant fans, and of course, you have alerting in your monitoring system. So availability starts on one single server. If you have a stable, good quality server, you will start to have good availability. And of course, we will replicate all of that to a second server. So at least we need 1 standby. If you need load balancing, you need more than 1 standby. Because if you load balance between a master and a standby, if the standby or the master fails, one single server is not capable of handling your charge. So you need at least more than 1 standby if you load balance. Use streaming replication, use replication slots. This is very, very important, because if one standby lags too far behind, you are going to lose it and reconstruct it. With replication slots, you are protected. Use geographic distribution. If we have 1 master and 1 standby, the master and the standby will be mandatorily in separate data centers that are at least 4 kilometers apart. And I don't know if you have studied the Paris map. If you look at the position of data centers, they are mostly by the Seine River, the Seine River, in English. And if you have flooding of the Seine River, you are going to flood several data centers at the same time. So we study the position of your data centers. The path between data centers has to be doubled. Everybody knows, and everybody has heard of the men working by the roads that will just break your fiber optics. That happened at Le Bon Coin 2 times this year. If you have multiple paths, no problem. When we talk about load balancing, I already said that you need more than one standby. And don't forget the spare server. Here is one minimum infrastructure for a very critical application at Le Bon Coin. We have at least one master, one spare standby, at least one extra standby for load balancing. And to load balance, we use high availability proxy, AJ proxy. Christophe said about PG pool. He's capable of doing it. It's capable of doing that. But in my tests, PG pool inserted around 10 milliseconds of latency in all my query calls. So AJ proxy is faster. It's some microseconds. So we go AJ proxy. And the separation between read-write and read-only data sources is done by the applications. So all Le Bon Coin developers work with 2 data sources, and this is not a problem. Well, let's talk about backups. Yes, pgdump is a kind of backup, in my opinion. I would explain why. So how we do pgdumps? We do it nightly. The archiving DBs are not dumped. So the 16 terabytes database, I won't dump that. It's too costly. It will take, I think, a couple of days to pgdump the 16 terabytes database. It costs a lot. I won't do that. I use the custom mode, -FC, if you know pgdump, or I use the directory mode for the database that go over 300 gigabytes. It's faster. I have fast disks, so I can use the parallel mode. For pgdump, it's mandatory to use directory mode if you want parallel in the pgdump time. All pgdumps are encrypted and sent to the cloud. I want my backups to be off-site. So here's how it works. Think about 70 servers over there. I have a virtual dump server that will connect to all databases and pgdump that. This server encrypts, so the data that's clear stays in my internal infrastructure. And after encryption, I save it to what we call AWS Storage Gateway. It's very practical stuff. You have 8 exabyte NFS directory. It's cool. So I can dump and forget about disk space. This is very nice. Another thing that's interesting about AWS Storage Gateway is that you can have one in each data center that use the same S3 bucket. So all your pgdumps are available everywhere in your infrastructure. I think it's very practical. And why pgdump? I will say here, I will say later, but I will say right now. Pgdumps are great to long-term storage. In these days of GDPR, I have to think about retention. So I have one-time delay that I have to keep my pgdumps. They are small, and they are good to keep for a long time. So that's why pgdumps are very, very important. Another reason pgdumps are important is that I can test it. I can test the restore, actually. So I don't test pgdump, I test pg restore. It's mandatory because your database may be corrupt. And when you restore a pgdump, you will see the corruption. It will shout an error for you. If you have, for example, a foreign key that's not respected because you have database corruption. If you have a pgdump corruption, if you don't test, you will never know. If you have an encryption corruption, you will never know. If your procedure is not good, if you don't test, you will never know. And if you have bugs in your automation, you will never know. So you have to test PG dumps. But the most important thing is you can measure the time to restore a PG dump. And you can act to make it faster by using more parallel workers and so on. So if you use PG dump and you don't test the restore, you don't have dumps. You don't have backups. So test is mandatory. And of course, I take physical backups too, because I need PITR, Peter. At Le Bon Coin, we chose to use Barman. It's a very nice tool. It works very well for us. If you use PG Arman or the other ones, it's up to you, but you need to have physical backups. How do I base backup? The base backup is the first snapshot of your database that you need for Python to work. In my case, I decided to be based on how much WAL per day I generate in my database. So if the database changes fast, I need to base backup more frequently, because I will have a larger WAL stream to redo in case of failure. So I need more snapshots, more recent snapshots. So if I generate more than 1 terabyte of WAL per day, I will base backup every day. If I'm between 100 gigabytes and 1 terabyte of WAL per day, I will make my base backups twice a week. And if I make less than 100 gigabytes per day, I can base backup twice a month. It's enough. And it works very well, for example, for the archive database. It's very slow moving. It's a very huge database. So I base backup every 15 days. It's OK for me. So I have Python, and I can test to the restore of physical backups. If I don't test, I don't have backups. Some Barman tips that I use at Le Bon Coin, it may be different for you. I prefer the Postgres method because under the hood, it will use PG receive WAL and PG base backup that are official, included in Postgres distribution tools. And with PG receive WAL, I can use replication slots, so if my Barman lags behind, it will just catch up by itself. I won't lose the Barman server. I also have geographic distribution for my Barman, so I have more than 1 Barman and at least 1 per data center. All Barman have archive, WAL archive, and I have to take care of disk space. I need disk space to at least have all the PG-based backups plus the WAL generated. And I have to deal with retention. Retention in Barman is a lot less than PG dumps. So the database that is 3 terabytes in disk, the PG dump is just 200, 250 gigabytes. But a Barman backup is 3 terabytes, plus 1 terabyte per day of WAL. It's a lot. How it works? So think about pairs of servers. So this server is backed up by Barman 1 and Barman 1 in both data centers. I have 1 Barman in data center B and 1 Barman in data center A. And the base backups are taken in an alternate fashion. So if it's a daily backup, today I will use this Barman to base backup, and tomorrow it will be the other one, and so on. That's how I do it. I don't make 2 base backups at the same time, but I have base backups in both data centers. So in case of 1 data center lost, I still have my backups. That's how it works. And I have multiple Barman to have disk space enough for all my databases. So we need to monitor and alert if I have problems in the infrastructure. How we do that? Someone knows Zyman? 1. How old are you? By 40s, like me? OK. So Zyman is a very old tool. but it's still alive. It is very nice, because it's very great for alerting. We are moving to Prometheus, don't know in English. But today, Xymon works for us. It's very nice. And Xymon is connected to PagerDuty. In case of problems by night, the dirty guy will have a phone call to intervene. We have two, Datadog, but that's most for developers and other users that need to see graphs in real time. They are used to Datadog, so we send some metrics to Datadog. But for me and the infrastructure guys, we use pgwatch2. It's a tool from Cybertech that reads pgstat statements and other things, and it's very, very nice. The front end's Grafana. It's very, very good. I just love it. I'll show you some graphs. This is Xymon. For every data, here are my database servers, not all of them, doesn't fit a single slide. And there are my PG dumps. So this block until this one, these are just hardware alerting. I have CPU failures, memory failures, fan failures, power supply failures, every kind of things that can go wrong in a server are there. And from here to here, they are Postgres-related alerts. So if I have idle transactions, connections, index bloat, inode problems in the operating system, if it's a standby, if it lags too much behind, if I have a lost slot, replication slot, because another server has disconnected, and so on. And the other stuff is for operating system metrics. So if something goes wrong, and it's not in Xymon, I will just put it in Xymon since the discovery. This is pgwatch2. It's the main screen. As you may see, it's Grafana, but customized by pgwatch and Cybertech. So you can see transactions per second, queries per second, mean time for queries, number of sessions, temporary bytes, database size in one single screen. Wall rate, so you know how much your database is writing, transactions per second and queries per second history, and so on. But my favorite screen is this one. These are the queries in my server, in my database. The first group is the total runtime. So I have the queries that took most of my server. It's the mean time times the number of calls. Here we have the slowest queries by mean time, or average time. And these are the most called queries. All this data is taken from pgstat statements. But if you click in one of the query IDs, you have graphs that show you average runtime, number of calls per hour, total runtime, this times that, and the shared buffers usage. It's really, really useful when you are trying to find out which queries are giving you problems, performance problems, and if you want to investigate if a query plan has changed, you have to optimize something. I just start by here. And we have exactly the same thing. A screen like that and another like that. For function calls, at Le Bon Coin, we still use a lot of PGSQL. Let's talk about data flow. How it flows inside Le Bon Coin. If you see that some applications have connections to more than one database. This is true for the legacy applications, the applications that work at Le Bon Coin after 10 years. we're starting to fix that by using microservices. So usually microservices connect to a single database, and we are starting to phasing out the legacy applications. This is a thing that is changing. But for BI, we have data flowing from database, from live databases to the data warehouse, and so on. So just to let you know how the applications connect to the databases. How do we do minor version upgrades? It's not without downtime. It's impossible to do that. It's too dangerous. So we decided that some seconds downtime at every time we do that is acceptable. First thing, we read the release notes when Postgres release a new version, minor version. We look to the release notes to measure the impact in our operations. For the operation, we have one DBA, one sysadmin, and one developer on call in case of problems. We start by the standby servers. It's a Postgres procedure that, if you read the documentation, they say to do that. Start by the standby. And after that, you put the master. We have some automation for that. We have some scripts that can connect to the servers and make the upgrades for us. So I don't need to connect to all my 70 servers to make that. And the whole process takes an hour. But the Le Bon Coin site stays up and running. And some parts of the website will be cut out during the operation for some seconds. It's really, really fast. So the impact for the end user is negligible, not noticeable. I think if you are trying to sell your shoes in Le Bon Coin, at the time I'm doing exactly the upgrade of the database that is responsible for the ad registering, you will see an error and 500 error. And if you try again, you will succeed. So it's really not a real problem. And we do that by night, so. But if you have to make a major version upgrade from Postgres 9.3 for 10, for example, the first things first, we try to keep the same version everywhere. Today, we are running Postgres 10. We have to decide when to upgrade. The last time, we were running 9.3, and the motivation to do that is that 9.3 was going to phase out by the community. So time to upgrade. And then we just jumped to the latest version at the time. We start by quality assurance and staging servers. And after that, after a couple of weeks of testing and bug fixing, we go on production. For that, we use PG upgrade. As said today, it's quite fast. It depends on the number of objects on your database, but it takes a couple of minutes to finish the operation by database, but the whole process took us 3 hours of work. And the same thing, the website stays up and running with some glitches for some functionalities. And we are studying how to do that. Since we have now Postgres 10, we have logical replication. We will try to make near zero downtime for the next upgrade. So we will start some Postgres 11 logical replicas. When we are ready, we stop the origin on Postgres 10. We update sequences. We just point the applications for the new Postgres 11 server. We start production, and with production running, we recreate a new physical replica in Postgres 11, but it's out of downtime. So the downtime will be between here and here, here and here, and it will take a couple of seconds, I think from 5 to 10 seconds. So it's really fast. When we migrate from 9.3 to 10, what happened? The function row to JSON has a changing of behavior. It was fixed in our application. We started to use parallel query. It's very nice, but because we have fast disks, so parallel query was great, and some queries that took 10 seconds, 15 seconds, today are 5 seconds, 4 seconds. We had some problems with execution plans and some queries that I had to change or optimize or create or drop indexes. It happens. It's changing on the Postgres optimizer. It's normal. I could use less auto-analyze in our database because there were changes also in the structure, Postgres structure for histograms had changed. So I have less auto-analyze. I could turn down the configuration. The function calls, I've had as the queries, I've had to optimize some ones. The problem with replication lag is lower today. I have less DDL locks. It's a feature introduced in Postgres 9.6. When you try to create a new foreign key, for example, you have less locking of the tables, especially on standbys. And at 9.3, we didn't have replication slot, and lose a standby was one thing that happened before. Today, we don't have this problem anymore. How do we apply DDL? We use Skitch and Git by the way of Gerrit's code review. I won't show all the steps here. It's quite easy. You make one script forward and one script backward. And this just works. What kind of incidents we faced at Leboncoin? Replication lag, that is mostly solved by the new version, and some configurations on auto vacuum. Changing of execution plans by optimizing some queries, we solved that. One nice incident with Skitch, since Skitch has one script forward and one script backwards, one developer tested it in staging servers. It worked, but the database on staging server was different from the production. So the Skitch, when he ran it in production, didn't go forward, but it went backwards. It dropped the tables on the database. Okay, no problem. We've just stopped production, and we've had to restore in point in time, just a second before the problem, and life goes on. So if you don't have PITR backups, think again. And one thing that was very funny was unattended upgrades. It was a fault. I will blame the Postgres community. I will blame the guy that is the manager of the Postgres APT repository, because today the Postgres contrib package doesn't exist anymore, but it's an alias to Postgres package. Since there was an upgrade of the Postgres server, and one of our scripts is still installed the Postgres contrib package that is an alias today, it just upgraded the Postgres version, the server version. And it was 20 seconds downtime for stop-start Postgres. So it happens. When we go to the cloud, how do we decide to go to the cloud? It all depends on a lot of things. First things first, instance types. Today, if you look to Amazon, types of instances available for databases that are very large ones, if you look at that server that I showed out for you, it has 160 cores. Today in Amazon, I think we have it. If we don't have it yet, we will have some time. But since we already have data centers, network, energy, everything that we need to run the site on-premise, the cost on-premise is still very, very low compared to go to Amazon. For this kind of loads, for a very huge database, it's more expensive on AWS. So the huge instance still on premises. There are variables that I can't control when I go to the cloud, like disk type. Christoph said today you have to share the disk with 100 clients, Amazon clients, so you never know what you have, and we need to control these variables. And another thing that, for me, as a Postgres guy, a community guy, the more important is vendor lock-in. We can't take physical backups from RDS, for example. And we can't make a physical replica from RDS. Today we can do logical replicas. Things are changing, but I don't like this kind of lock-in. If I need to migrate my database quickly from Amazon to anywhere else, I can't do that today. So I prefer to keep my really critical data inside my data centers. But new scenarios are coming, and for our small elastic, when I say elastic, there are some databases that changes fast in number of calls and number of users, and for that, Amazon is great. You can put more resources, you can take out resources when you don't need anymore. So these databases are on RDS today. We have some databases on RDS. I would say about 10 or 15 databases are on RDS. I don't have the right number. And another thing that I use the cloud to is for the commissioned databases. For example, one server that we had about a terabyte database for a service that doesn't exist anymore, but I have to keep the data for audit purposes in the future. I just restored it on RDS, and I don't need the database to be running. I took a snapshot of the database, and I shut down the RDS. So I pay for the snapshots. It's not expensive at all. And to finish this talk, when someone arrives to me and says, why don't you go MongoDB? I just ask back, with all of this, how would you migrate all of that to MongoDB? And how would you have all the Postgres functionality that we use, all the Postgres features that we use on MongoDB? It just doesn't exist. So, no MongoDB for us. But we have some NoSQL for example, time series on InfluxDB for the Postgres monitoring. InfluxDB is great for time series. We have Elasticsearch for searching. Before we had a house-made indexing system for the website. Today we use Elasticsearch, it's great. It works. And we have caching on Redis. It's great. They are made for that. They are specialized on that. I will never put all my production on Redis, for example. It wasn't made for that. That's it. If you ask if we have another engines, so Postgres, we have more than 70 servers. MySQL, we have 5 or 10 servers. And Microsoft SQL, we have one server. It's a proof of concept, in fact. It's running on Linux. Yes, didn't you heard about it? Will I ditch Postgres for put your NoSQL there? Never. So that's how we handle Le Bon Coin. We are the most important website for the French people. We are just after the GAFA stuff, Google, Amazon, Facebook, Wikipedia, etc. So that's it. It's web scale, Postgres. Thanks. I'm finished. Just one thing that I forgot. There are a couple of blog posts about Postgres backups that I've made recently. You can take a look at Le Bon Coin engineering blog. I'm open to questions, if you have some.
I have a question concerning your Elasticsearch clusters. Is it on Amazon or on-premise?
I don't know exactly. I have to ask my partners, developers that are over there. They are on premises. They are on premises.
And it was because of the cost, or
I really don't know. I think it's because of the Elasticsearch version. I've heard about it. If you go to the managed Elasticsearch, it's not the same version that the community Elasticsearch. So they decided to use in-house Elasticsearch.
Okay.
I think it's a matter of version and functions available.
Thank you.
Thanks for the presentation. You said you don't use PG pool, but you use HA proxy. What's software or something scripts to to promote automatically the master to the secondary?
We don't have automatic failover. There are scripts that do that for me, but there are a lot of things that can go wrong if we go automatic. We could use path from Dalibo, or we can use Zalando Patroni, but there are a lot of things that can go wrong. We decided to look at what happened before failing over. We've had some problems, like one failing power source that went back in a couple of seconds. If we had automatic failover, it would fail over, and a lot of time to reconstruct the old master. So we decided to just don't go automatic in this case.
Yeah. You mentioned that you're using InfluxDB for time series. Have you looked at TimescaleDB? It's a Postgres extension, which supposedly performs.
Actually, InfluxDB is used because Grafana connects directly to that, and it works transparently. It is included with the PGWatch distribution, so we didn't touch that.
Okay.
But maybe it's possible to use Postgres, yes.
I think Grafana connects also to time series DB, but TimescaleDB.
Okay. Thank you. I will have a look. Thank you.
Thank you. How did you install the Postgres? From sources or from packages?
From the official repositories. If it's Debian or Red Hat, we use the official repositories from the community, from Postgres Global Development Group. So it's yum.postgres.org or apt.postgresql.org.
And you install Postgres on the bare metal machine or in VM?
I didn't get it.
In the physical hardware, you install Postgres in the VM?
Yes.
In VM, no?
Everywhere we use Postgres, be bare metal or virtual machines, it's the same thing.
The same thing.
It's the same code in Puppet. We just have to handle different configurations, but it's the same binary, everything is the same.
Okay. Thank you.
Thank you.
For your streaming replication strategy, are you doing replication in cascade?
It all depends on the moment. Usually, we don't use cascade replication, because if you lose the first standby, you lose all the chain. But if I have, for example, network saturation between data centers, I can reconfigure the replication to use cascade replication. I had to do that before. We've had when one of the fiber optics was cut out, we've lost a lot of network capacity, so I have cut out the direct replication to use cascading replication in that case. But usually they are all connected to the master.
Okay.
But Barman. Barman are connected in a cascade fashion.
Okay. Thank you.
What is your retention for the backups with Barman?
For Barman, it all depends on the server. For the biggest one, it's about a week. And for the smallest ones, about a month. It's not too much. The physical backup is used for disaster recovery. We don't need long-term storage. That's why we use PG dumps too. So for me, PG dump is a backup. That's it.
Okay, thank you.